Well, hello guys, and thank you so much for joining me again. Recently I published a video all around this mini-tune generator alternator starter tester. OTC bought mini-tune out and then they dropped the line as well. They're just not that much in demand anymore. And you can still find generators, starter testers in parts stores and so forth, but that's, you know, this throwaway society, even that's gone by the wayside for the most part. So we have a problem. When I picked this up and I started doing a little research on trying to find parts for it, because I got no accessory leads to plug in your different alternators and so forth. I at least wanted the universal one for Delco alternators. Can't find anything, can't find any website that offers anything for this, including advice. When you start researching, all you can find is guys like me have purchased these and they are looking for help. Now I've gained a little bit of knowledge in the meantime, so I'm going to spin up another alternator with you, spin a starter with you, and then we'll go back to the generators. One thing that is available out there is you can get on eBay and order Xerox copies of the connect charts. So you just go through, find your alternator in here, hopefully you have the correct plug it needs, and then it shows you how to hook it up, and it shows you on the panel where your switch positions should be and what your indicator lights should show while you're testing it, as well as the volts for an alternator or generator, or the amperage for a starter. Once again, for the majority of my purpose, things that I'm going to be testing, I really wanted the universal harness. This is for older Delcos, and then a stator and a field alligator clip. I don't have that. All I have, luckily I do have this, is the front panel tester lead leading up to here. I have nothing else. So from here on out, everything that I will be hooking up, well, at least as far as the alternator is concerned, is homebrew. It's jury rigged. So, you know, there's that. But I suppose you can go through, they also have a chart here, you can go through part numbers for your alternator. It tells you what chart to use, and then from there it will tell you what plug to use. And I believe there is also a page here, starter testing instructions, as well as special notes for alternator and starter testing. In the first video, I spun up this old 1960s alternator. It's an RF style plug alternator, probably off, I'm guessing, one of the Impalas that's been in my family at one point or another, and it was good. Now the alternator and the tester or starter we're going to be doing today are both off of my 86 GMC. So this is a 1-2 style Delco plug. You can see it here. So for that older one, I just grabbed an old pigtail for an alternator, the RF style, and put 2 spade connectors on there so I could plug them in the correct spot on my plug. So for this 1-2 style, did the same thing. And you can see here on our page for the 1-2 style plug, it just shows you which wire should be in what position on the universal harness lead, and I just, you know, this is simple stuff, so it's obvious where it goes. Okay, now according to the picture, we know what switch needs to go where. Alternator on, obviously, B system, negative ground, 12 volt. When we spin it up, we see 1 on, the load indicator light should be on, and stator relay, diode trio, and defective lights should all be off. Over here on the control side, where we operate the machine, says we need to spin it clockwise, so I will click up when we do that. and then hold on the alternator with an internal regulator. And you can see on the gauge between 13 and 17 volts. They have a mark there that shows it is working. So here at the back we're going to hook up our clips. This plug is pretty obvious. The red goes to the battery terminal, and then we just find a good ground on the case. We're going to spin this up. We have 16 volts on the gauge and just the load indicator light is on. Now that we're fairly comfortable that our alternator is going to work, we're going to turn our attention to the GMC Starter. Now I just pulled this out of my stash up in the loft of this shed here, so I really have no idea what's going on with it. Originally there would have been a strap here to hold this thing on. Obviously someone didn't think it was necessary. We're going to connect our starter leads to it. So I'm just going to ground the case out with the negative clamp. I'm going to be careful and maybe just grab the end of the positive battery stud here. Try not to short anything across. There we go. Okay, now this positive lead is like our ignition wire. So that's going to go, I can't see a thing. I think it should be this one. Yeah, there's an S, and this one might have an R on it. And I realize this is all Delco stuff. This is what I have, you know. Okay, then the negative clamp, if your particular vehicle pulls power off of this other stud on the end of the solenoid, you can put this clamp on here, and then we have an indicator light that tells us if this indeed is getting power. May or may not apply to your particular vehicle. Okay, when I spin this up, the only thing we need to use is the starter icon switch. We're going to hold it for 3 to 5 seconds. The instruction book does not want your needle to drop below 10 volts just for the sake of the tester, I suppose. I'm pretty sure this is a Delco 5MT for an 86 GMC, 80 to 130 amps. So I'm just going to hold this and spin it up. Okay, so at the lowest reading it was at 120. So we're right in there where we need to be, and it also did not drop below 10 volts. So it was very good. I'll do that once more with a close-up on the gauge. We'll move on from here. You also notice once it gets wound up and the needle comes, it stays steady at a certain point. It does not keep falling, and that's a good thing. Okay, now we're going to turn our attention back to the very beginning of why I made the other video to begin with. You know, my childish whining and everything and so forth. And that was, can we test generators on a generator tester? 6-volt option. Seems fairly obvious that we should be able to, despite everyone telling me that you can't do that. Now, I have videos that you can watch if you haven't on the charging system for the 48 Chevy and the 38 Buick Special that we went through. And it was on the Buick's video, I think I mentioned that whenever I try to do an in-depth study on how generators and regulators work and in connection with each other, you know, really get into the theory and the actual scientific understanding of it, I snap out of my reverie after 5 minutes and find out I've been just humming Twilight Zone by Golden Earring. So let's see if we can get a little bit more understanding on this. So this is a late 50s, early 60s generator, 12-volt generator that I came across the other day and decided I wanted to test that as well. And we'll get to that in a second. But let's go over here. So when you have your generator case and you see these screws on the outside, those are holding, there's a concave shoe facing the armature inside of there, and they're surrounded by the field coils. And this is an electromagnet, is all a generator is. And the strength, the output you are putting, this generator is producing, depends entirely on how much you are exciting or sending into the field coils. So more current going into the field coils, the stronger the magnetism gets, and the stronger the output going back out through the armature, through the brush and onto your regulator. So basically this thing works just like if you had a horseshoe magnet. Make more of a horseshoe, not a square. That's really bad, but you understand. If you have a horseshoe magnet north and south and you pass a complete circuit through it, a conductor, which is what your armature is, you're going to create magnetism, or you're going to create electricity. So I suppose you could even try that at home somehow if you have a horseshoe magnet. I do not. Otherwise I'd probably try it here with you. But if you had a horseshoe magnet, you have a complete circuit of a conductor and you pass it through there, somehow spin it or whatever, you're going to be creating electricity in the conductor. So this already has residual magnetism in those pole shoes, but it's weak. So that's why on a generator, when you start the car or spin it by hand, you can generate power, but it's very weak. A car at idle with a generator, it's very weak. You increase the magnetism of the shoes by sending more current into this magnet, you're going to increase the output. As I understand it, that's the theory behind it. Now everything is then regulated at the regulator. Your current going into your field coils to determine the strength of your output so that you do not blow up your battery and all your lights and so forth. And then of course there's also a cutout switch in the regulator that prevents current from flowing backwards from the battery back to the generator when this is idling or not in use. So that's just as simple and as boiled down. I'm the kind of guy that just likes things as simple as you can make them so that I can understand it. And that's as simple and as boiled down as I understand it. And I hope I'm correct. But we're going to hook this 12-volt generator up that I came across the other day. I've got it grounded at the case down here. I've got my armature stud with the positive lead, and then in our pigtail, the one that I know, if I had the universal connector, this would be the field terminal. So I have my homemade wire going to the field there. Now I'm not sure. We'll see if I need to excite this field with the energize button. I did the first time that I put this thing on here, and then it just took off. So we'll see. But anyway, again, Gen A system, negative ground, 12-volt generator. Going to turn it clockwise, hold down the alternator generator. It is non-regulated internally, obviously, and we'll see where the voltage takes us. And if it just wants to hang around low, I'll just bump the energize button and then see if we go up to a proper voltage coming out of this thing. Nope, it doesn't need it. So we're right at 15 volts output. And that is at this speed it's turning, roughly 2,000, 2,500. Obviously, the faster you turn this, the more it's going to create. So there's a 12 volt generator for you. Let's put the 6 volt back on. Alright, we're hooked up the same way. My armature and field terminals are just opposite each other on the 6 volt. Just need to change that to 6, do the same thing otherwise. And looky there, 7 volts output. Up, 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 up. Up, up, up. Having a little hiccups there, and I'm not sure what that's about. So everything's cool, right? I can do alternators, starters, 12 volt generators, 6 volt generators. Not really. Before I recorded the last clip, I threw this 6 volt on here before I did the 12 volt, spun it up, and the same old result. Only a volt and a half, 2 volts coming out of it on the scale. Even if I hit the energize button and try to excite the old field, you know. But just like when I found that 12 volt generator, I threw it on here, I hit the excite button on that to get it going. You know, it's just been laying around in storage. The polarity was probably lost on it and the magnetism. Then it went up to 15 volts. Then I put this back on, spun it up, and then we had a good 7 volts coming out of this thing. So the question is, why does this tester require spinning up a 12 volt generator before a 6 volt generator will provide a reading? Obviously it has, or in my mind, it obviously has to do with providing power to the field coils to get that excited. But we have a capability of testing 6 volt equipment on here. So it says. So why doesn't it just do it to begin with? I don't know. There were a couple of you that left me good comments and advice on the first video. Some of you had worked at auto electric shops in the past and you had tested many of these things. If any of you have any ideas, don't hesitate to leave them down there. It would be kind of silly that every time I needed to test one of these, I had to put a 12 volt generator in there first. But if needs must. So in the end, when it comes to generators, you know, I'm pretty certain this is working somewhat, the test bench alone, but one of my main desires was just the ability to spin one up here, hook a battery and a regulator in line with it, and be able to test and make adjustments to that before I even have to put it on the car or I even have a car at all. Now, one mistake I did make on the previous video is that I set my tester to alternating voltage coming out of this thing. Probably alternating current too, I forget what I did, but it is in fact producing direct. So that's one on me. So this looks like a rat's nest, but we have an exact representation of what's going on in a car here. And got our power coming in, actually going out to the positive terminal of the battery. We are grounded to the base of the regulator, as well as grounded to the case of the generator. Everything's falling apart on me now. Armature wires hooked up, field wires hooked up. I have my direct current voltage meter on, as well as my ammeter in line with the battery. Now this battery is fully charged, so probably won't see much current flowing to it. But right now we can see we have 6.39 volts. I'm assuming you can see that. Let me get in a little closer here so you don't have a glare. There, we can get both screens. 6.39 volts at the battery, and nothing and nothing armature and field, which should be the case. We'll spin her clockwise. I had a little over an amp earlier. So our voltage is a little higher going to the battery. 6.7 there. There we have 1.8 amps going to the battery. So all sources indicate that generator's working, regulator is in adjustment considering we have a fully charged battery. And there you go, guys. This is going to be it for this now. I know, but I hope it was at least somewhat interesting. Mainly I was trying to help out all the other guys on the internet that have posted questions about spinning up one of these and not knowing what they're doing. I really appreciate the comments and the helpful advice that you sent my way after the first video. I just take that for what it is. I really do appreciate it. And I can look forward to playing around and spinning up and rebuilding old things. That's the spirit that I'm doing this in, is in this throwaway society. I like the old ways and I like to rebuild things. So there you go. Thank you for joining me. God bless you guys. See you on the next one.